For our last lesson on circle geometry, we're going to talk about tangents to a circle. And so first of all, there's four key ideas here. Number one, a line that touches a circle at exactly one point is tangent to the circle. So as you look at the circle here, there are two lines that touch at only one point on the outside of that circle, and those lines are both tangent, we say, to the circle. Okay, what does that mean? Well, let's look at some other ideas here. Point A is known as the point of tangency. So let's just put an A here. I'll just, that little red dot there, point A, that's the point of tangency. Now it says here, a line that is tangent to a circle at a point A is perpendicular to the radius. So if I draw the radius, we'll call the center of the circle here C. If I draw the radius right there, so let's just draw that. Let's change color. Okay. If I draw a green line, which will be the radius here, the radius there, it says, is perpendicular. Those two lines are perpendicular to each other. The tangent line and the radius are perpendicular. That's all it means. Okay. So every time you have a tangent line, it is perpendicular to the radius of the circle that goes through that point where it touches the circle. Number, let's see, what was that? Circle perpendicular. Okay. And number 4, a chord drawn perpendicular. Okay, let's go number 4 here. Perpendicular to a tangent line at the point of tangency. So let's just choose this point here. We'll say B. And if I draw this, if I draw a point, it says chord drawn perpendicular to a tangent line at the point tangency. So I'm going to draw this at 90 degrees to that line. It'll look like this. Okay. And it's 90 degrees. And it contains the center of the circle. And if I drew it straight across, I kept going with that line. I'll get it lined up here. It would be a line that is a diameter. So this red line now is the diameter, or two radiuses put together, because it goes through the center of the circle. Okay, so those are the key ideas of this last section of circle geometry. So let's take a look at a couple of examples to help us see how we're going to use this information to solve some problems. First question, a dog is tied on a leash to a clothesline pole in the backyard. There's the pole, okay, there's the leash, and there's the dog, a little red dot at the end of that line, leash. And it says the leash is 5 meters long, which I've labeled there, 5 meters long. And the pole is a perpendicular distance of 5 meters from the corner of the house. That means if I draw a line from the corner of the house to that pole, which is actually the center of that circle, right? Because the dog goes around a circular motion with that leash. If I draw a line from the house to there, that is perpendicular. It's 90 degrees. 90 degrees to the corner of the house. Okay? So the dog can just go to that corner of the house with a leash. How long it is, 5 meters long. And that it says, and because that's where the leash goes, it tells us there, this is also 5 meters. That distance right there. Now it says the pole is a perpendicular distance of 5 meters from the corner of the house. How close to the cat door can the dog get? So if the cat door is at the corner of the house over there, so that basically is going to be 16 meters away. So let's draw that in here just to get an idea of where it is. Okay, so there it is. Now how close can the dog get? Well, we know that from here to here is 5 meters. Excuse me. What we need to know is this other distance from here, that's how close he can get. I don't know, call it x, say. Don't know, what is that distance? Well, if we knew the whole distance, we could subtract 5 from it and get get the x, but we don't know the whole distance. But wait a minute, what do we have there? We've just drawn, by drawing that last red line, we've just gone a 90-degree triangle. We know one side is 5 meters. We know this side here is 16 meters because it's the length of the house. So we can get the hypotenuse, which is the side opposite the 90 degrees, by using Pythagoras' theorem. So let's do that. So we got a squared plus b squared equals c squared. And we're going to put here 16 squared plus 5 squared equals c squared. And so we're going to do a multiply 16 times 16 and get 256 plus 25. 5 times 5 is 25 equals c squared. Add those together and I get 281 equals c squared. So how do I find c? I need to take the square root of c squared to get c, and I square root this side as well, and I get c equals, okay, let's put this in now, 2, okay, square root, where's square root of 281 is 16.8 meters. That's how long that hypotenuse is. Okay, now we already mentioned that c equals x plus 5 meters. So c is 16.8. And we just subtract 5 to move it out of there. So let's do that. Let's subtract 5 from this side. Subtract 5 meters from this side, minus 5. And those cancel out. And this is going to give me x equals 11.8 meters. That's how close the dog can get to the cat door. Lots of room for the cat. Okay, so that's the first example. Again, we use Pythagoras, which is the common formula we use for solving all these problems. Just find a 90-degree triangle, right? Number 2, Nick is attempting to land his model plane when the wire breaks just as it touches down. What the length of the control wire is 10 meters, so I've labeled it there. 10 meters is the control wire. And the plane stops at location 74 meters from Nick. So Nick's in the middle of that circle. His plane was flying around in a circle attached to a 10-meter wire. The radius is 10 meters there. And the plane stops after it crash lands, as you might say. So basically it disconnected where it touched down. And the idea is once it disconnects, it just continues in the same direction. So that's actually 90 degrees. That's actually 90 degrees, which means that this side here we can call it D. D is tangent to the circle, because it just touches that one point and then it continues on out the other side like that. Okay, it actually is a tangent point there. That's a tangent line. And so how do we do that? Well, it's a 90-degree triangle. I want to find D here. I know the hypotenuse is 74. That's 74. This is 10 over there. So let's fill the numbers in. Let's just do this calculation here. So let's pull this down a little bit more. Give us a little bit more room. Once again, we're going to do a squared plus b squared equals c squared. And I'll just make d as, we'll call d a. So this will be d squared. I don't know what that is, that side. The other side, the other leg is 10 meters. And that's equal to the hypotenuse squared, which is 74 meters. Okay, so what we're going to do here is we're going to square these numbers. Yeah, so d squared plus 100 equals 74 squared. And that's, I'm going to use a calculator for that because that's going to be pretty difficult to do. 74 times 74 equals 5476. So 5476. And now I'm going to get rid of that 100. So d is by itself there, minus 100. That's gone. I get d squared, oops, not dr, what am I doing here? D squared equals 5376. Okay, and how do I find d? I gotta take the square root. So let's do that. Let's just take the square root of both sides here. And I get d equals the square root of 5376. So let me just find that here. Square root 5376 equals 73.3 meters. 73.3 meters. So there's our distance that the plane traveled actually after it broke off free from the wire. And that's this lesson.